Hello students, today from chapter 1, the subtopic which we are going to do is measurement of time. And you already know that commonly we use a pendulum clock to note time, and which is based on the periodic oscillation of a pendulum. Now what's a simple pendulum? To define it, we'll be giving a proper definition. A simple pendulum is a point-heavy mass known as a bob suspended with a rigid support by a weightless and inextensible string. In your book, it is given massless, but prefer writing the answer as weightless and inextensible string. Both are correct, right? So, but the preference is given always for weightless and inextensible string. If you are asked to draw a diagram for a simple pendulum, I have given you two diagrams. Now, one is simply to identify what is a simple pendulum, which is a string has been shown, it has been fixed with a support, and the length of the pendulum always will be considered from the fixed support up to the center of gravity of the metallic bob. But if you have to explain other terms, then we'll be showing this type of diagram where the different positions of the pendulum bobs have been shown when it is oscillating. So to explain various terms, we can say one by one. Let's have oscillation. One, to and fro motion. That means from the pendulum, either side the pendulum is moving. The bob is moving on either side of the mean position. This is the mean position. One, to and fro motion of the bob is known as oscillation. Now another important term which you have to understand is time period. So the time taken by the pendulum to complete one oscillation is called the time period, and we represent it by the symbol capital T, and the SI unit of time period is second, which is represented by small s. Next term is frequency of oscillation. That means the number of oscillation a pendulum bob is going to make in 1 second will be known as the frequency of oscillation, and it is represented commonly by the letter F or N, but prefer using the letter F. And the SI unit of frequency is hertz or per second. Now when you write per second, you'll be writing second minus 1. That's known as per second, right? And if you're asked to have a relation between time period and frequency of oscillation, then you'll be writing T is equal to 1 by F, or you can also write as F is equal to 1 by time period. Any one of the two. There comes another term, that is amplitude, which means the maximum displacement of the bob from its mean position on either side. Now once one oscillation will be taking place, both the side the bob is going to complete same distance, right? So that's going to be the amplitude of oscillation. It is represented by small a or capital A, and the SI unit will be meter. As I told you before, the effective length will always be from the fixed point up to the center of gravity of the pendulum bob. Anytime for your practicals and all, you have to measure the length. You'll always take it from half of the bob. That means because you can't exactly find out the center of gravity point of a spherical bob, so you'll take it halfway. From the half of the bob up to the fixed point will be taken as the effective length of the pendulum. It is always going to be represented by small l, and SI unit of effective length will be meter. If you are asked to plot a graph between square of the time period and length of the pendulum, then you'll find that it is going to come as a straight line, oblique line, right? more or less passing from the origin. So t square you will always take on the y-axis and length will be on the x-axis, because we have said graph between square of the time period and length. Whatever is spoken first, that will be on the y-axis, and whatever is spoken later, that will be on the x-axis. And the slope of this line will be giving us the acceleration due to gravity of the place. So how to calculate the acceleration due to gravity? We'll be finding the slope of the graph first by using the formula perpendicular over base. That's a simple one. And this slope will always be a constant at a place, and it is equal to 4 pi square by g, where g will be the acceleration due to gravity of that place. So by using the formula, g is equal to 4 pi square upon slope of t square versus L graph. What we have done here, t square versus L graph, whatever is going to be the slope, that we are going to use in this particular formula to find out the g value. If you are asked any time, name the factors on which the time period of a simple pendulum will depend, then you are straightforward, you are going to write the factors only. And basically there are two factors. One is length of the pendulum, and secondly the acceleration due to gravity. If you are asked to explain how these factors are going to affect the time period of a simple pendulum, then you are going to give the explanation, like the time period of oscillation is directly proportional to the square root of its effective length, which means t is proportional to square root of L, or if I square both the sides, it will come out to be t square is proportional to length. The second factor, acceleration due to gravity, you will be explaining as the time period of oscillation is inversely proportional to the square root of acceleration due to gravity, which will be representing as t is proportional to 1 upon square root of acceleration due to gravity g. Remember, the time period of oscillation will not be depending on either the mass of the body suspended, that means the bob, or the material of the bob, or the amplitude of oscillation of the pendulum. That means, in short, you can say any factor other than the length and acceleration due to gravity given to you, your answer will be that time period does not depend on these factors. Now coming on to a special type of pendulum, that is seconds pendulum. So a pendulum whose time period is 2 seconds, we call it as a seconds pendulum. And if we are asked any time to find out the frequency of oscillation of seconds pendulum, we can easily apply the formula f is equal to 1 upon time period. So frequency will be 1 upon 2, which means 0.5 Hertz. So easily we can say the time period of seconds pendulum is 2 seconds and frequency of oscillation is 0.5 Hertz. And you can solve number of numerical problems based on the basic formula of the time period of a simple pendulum, which is given as t is equal to 2 pi under root L by g. Rearranging this formula, number of numerical problems can be solved.